can also use the unit circle to get an idea of what the cosine or the Cos graph looks like. So once again, if we do our unit circle, and we'll do some axes here. Let's work in radians here. So we got 0, pi on 2, pi, and 3 pi on 2, and 0 also is 2 pi. So if we put those out there, we've got 0, and we've got pi on 2. Let's get over to here. So we've got 2 pi. We've got pi. Halfway between there will be 3 pi on 2. And halfway between pi and 0 will be pi on 2. Okay, so we want to see what the Cos graph looks like. Now we know from our unit circle, angle theta, P point xy, this is radius of 1, that the cos of theta is equal to x over 1, which is equal to just the value of x. Now because of the unit circle, the greatest value that x can take will be equal to 1. So once again, we're going to go, just like with the sine graph, we're going to go between +1 and -1. So the greatest value that cos can take is +1, the least value it can take is -1, just like with the sine graph. Okay, when we've got 0, point P is there, what is the x value there? That'll be equal to 1. So the Cos graph is going to start at that point up there at +1. By the time we get up to there, the value of the x value will be equal to 0. So that point will be on my graph. When I get over here at pi, what is my x value there? It'll be equal to -1. And down here, what is my, this will be the coordinate 0, -1. What is the x value there? At 3 pi on 2, that'll be 0. And back up here, what's the coordinate of this point? This is 1, 0. What is the x value there? It'll be equal to 1. So I've got 1, 2, 3, 4, 5 dots there on the graph, and it'll look a little bit like that, between 0 and 2 pi. So that's the cosine graph or the Cos graph. Once again, this is what we call one period. In other words, this section of the graph is repeated indefinitely. So if I was to get this point and move it over to there, the next part of the graph would also look like, etc. Keep going, and would look like that going over there. And if I was to get this part of the graph and move it across, we would have also, it looks like that. All right, so it keeps on going indefinitely. So cos is simply equal to the x coordinate in the unit circle, and you know that it goes between -1 and +1. So the Cos graph, in some ways it looks like a sine graph. If the sine graph actually, you can see that the sine graph starts here and goes up. So if the origin was there, or another way to look at it is if the origin was there. So there is some similarities between the sine graph and the cosine graph. It's just been moved across, in fact, by pi on 2 or 90 degrees. Okay, so the cosine graph.